session, we are going to record this and we are going to upload the entire lesson onto the YouTube channel. So that we can have access to that. So as I'm speaking to you right now, the recording has already started. So let us go through this. This is a document which I'm going to share to our WhatsApp group. Examination guidelines. Whatever I'm going to write here on the screen, I'm also going to share the notes on the WhatsApp group. And we're going to also be sharing some work that we're going to be doing via the WhatsApp group. And if you want to, you can also email it to me. Right, let's go to the content of this. Let's look at this. How does the structure of this subject look like? And I'm going to skip this and start from here. This is how the structure of your physical sciences is going to look like. Comprising of two things, physics and chemistry. The paper is 3 hours each. Yours won't be, I'm not sure if you guys have already been registered, but I think for most of you, you're going to be writing in May. So it won't be October, November. I don't know. For some of you, it will depend on your timetable. Please go and check the timetable. The sooner you get it, the better it will be to know. Okay, so this is what I want to show you. So these are the topics that you're looking at. So whenever we are doing our budget of time, we should be guided by this. This is what should inform our planning. This is what should inform how we do things. So as you can see, there are 4 strands of content topics in physics: mechanics, waves, sound and light, electricity and magnetism, then matter and materials. Then go to your chemistry. Stella?
Sorry, sir. I wanted to say I actually don't see anything on my screen.
Is that so?
Yes.
Guys, is there anyone else who's experiencing the same problem? Let me check.
No, sir.
Okay, Stella, you know what you can do? Leave the meeting and then after, and then join shortly afterwards. Just
okay.
leave the meeting and join. It should refresh. Yeah. Okay, so guys, this is the structure of your paper. Paper 1, mechanics, wave, sound and light, electricity and magnetism, then matter and materials. Then we go to your paper 2, chemistry. Are you sorted, Stella?
Yes.
Great, fantastic. Chemical change, then matter and materials. By the way, when they say matter and materials here, this is simply put your organic chemistry. So organic chemistry of your paper 2 is what makes up 58. If you work out the average, 58 out of 150, that is about 40%. So 40% of your work in paper 2 is organic chemistry. Therefore, you have to master this. Then the other topics in paper 2 are distributed into like 60%, but the big chunk is your matter and materials, which is organic chemistry. So I hope we are all following it. That is the content. But what else can you get out of this document? From this document, there is a lot of things that you can get, which you must look into. It tells you about skills in physical sciences. I'm not going to go through this word for word, but this is what you need to have. And then what else? Look at that, look at that, look at that. So you guys will read through this. I'm not going to be wasting your time because I trust that we all can read. So I'm going to share this document with you. Make sure you familiarize yourself with the content of this document. What's going on? Right, then we go to this, which is what you're going to be doing. We're going to be starting this with this. So it goes on to telling us, now it zooms in into what is there into this content. Newton's laws and applications of Newton's laws. Then they start to tell what do we need to know. Different kinds of forces. The lesson has officially started. Different kinds of forces: weight, normal force, frictional force, applied force, tension on strings or cables. Then it goes on to say, define normal force. Every single definition in the rules that we're gonna be, when they say define something, we're gonna have to take a definition directly from this document. Anything which is not from this document, unfortunately, will not be marked correct. That is why this is called the examination guidelines. So whenever they say to define something, this is what they expect you. Define normal force. Normal force is the force or the component of force which is surface exerted on an object with which it is in contact and which is perpendicular to the surface. So all the definitions. Karabo seems to be experiencing some technicalities. I don't know. Karabo, are you okay? Karabo, are you okay? Okay, guys, okay, hoping that Karabo is fine. So this is what we're gonna be doing. So our first topic today will be Newton's laws of motion. We're gonna be following the order of the end of the question paper. So we start with Newton's laws of motion, after which we will then switch to paper 2 and do organic chemistry. Finish with organic chemistry, come back to paper 1 and do something else. So we're gonna be alternating. Physics, one topic, chemistry, one topic. Physics, one topic, chemistry, one topic, until hopefully we finish. So let us get started. Once again, ladies and gentlemen, my name is Sandy, and then we are officially started. Newton's laws of motion. One thing about physics, and everyone else, one thing about physics is that you can never understand what physics is if your mathematics is not good enough. Otherwise, you're gonna keep on memorizing. But for physics to have meaning, we need maths. That's a secret. Two things that make physics really complicated is one, communication. Read to understand. Read to understand. That's the first thing. And secondly, process the information mathematically, analyze things mathematically. So you're gonna see that whilst we are doing physics, many times we're gonna be having some maths interaction. So our maths must always, at all the given point in time, be here. So that is the first thing that I want to share with you. So Newton's first law of motion. There are 3 laws. I hope we are all familiar with those laws of motion. Are we not? No. Maybe before we get into that, let's speak about forces. Right. When we speak about mechanics, mechanics can be divided into 2. That is kinematics and dynamics. In kinematics, we are not concerned about that which causes the change in the state of motion. But in dynamics, which is what we are doing here, we are concerned about that which causes the change in the state of motion of an object. And that which causes the change in the state of motion of an object is a force. Force does not create motion. Force changes the state of motion. Listen to this carefully. Force does not cause. It's not the cause of motion, but it affects the motion of an object. Therefore, when you see something changing, like when you see a car accelerating, you must know there is a force behind that. But it does not cause the motion. It changes the state of motion. Any questions? And everybody? It's very important that we understand these forces. So, these are not all the forces, but the ones that we're going to be focusing on include the likes of, firstly, your normal force. Like I said, whenever we study physics, we have to bring our mathematics at all the times. So when we speak about the word normal has been taken from the mathematics. Okay? We've borrowed this from mathematics. Because all that physics is applications of mathematics. That is what physics is. We bring life to maths. We make maths to be useful, to be meaningful. So the word normal means at 90 degrees. The word normal is taken from mathematics, but normal, the key word here is perpendicular, at 90 degrees. Normal force is a contact force. Normal force is exerted by the surface. And the most importantly, normal force is acting perpendicular to the surface. And the normal force acts upwards. Relatively so. Let us put this in inverted commas. Relatively so, but it is upward. There has to be the contact between two surfaces for the normal force to exist. So when you see something that is hanging and it is not in contact with the surface, you cannot speak about the normal force. It has to be in contact with the surface. We say a surface, or we can say the plane. What is a plane? Cartesian plane, mathematics. What is a plane? What is a plane? A plane is simple. The floor. This is a plane. X, Y. That is a plane. Look at the corner. If you are seated somewhere, look at the corner. You will notice that the corner of the house has got these three planes. X, Y, and the Z plane. Look at the corner of the house. So I'm currently walking on the XZ plane because this is the floor. I'm walking. It's a two-dimensional plane. XZ plane. So when we speak about the plane, this is what we are looking at. That is why in mathematics we say Cartesian plane. Cartesian plane. It's a system that we use to explain the relative position of an object with a reference to a certain point that we call the origin. Relative to the origin, where am I located? So it has to be like that. Normal force is an upward force exerted by the surface on an object. The object must be in contact with the surface. And this force has to be perpendicular to the surface. Number physics. Number physics. Questions before we proceed? So if an object, for example, is on the horizontal surface like this being the surface, then the normal force must be at 90 degrees with the surface and it must be upwards. That is what it means. Sipho sethu, zama, sicelo, karabo, Teutanix, sibaka, and Lilo. This has to be the normal force. It matters not how the surface looks like. Even if the surface is like when we are driving up the incline, it matters not the orientation of an object or the surface rather. All we know is that the normal force must be at 90 degrees with the surface. Perpendicular, that's a keyword. Perpendicular to the surface and upwards, relatively so. It matters not the orientation of the surface. Hamba physics. Hamba physics. So in mathematics, we do what they call transformations. One of such transformations is rotation. So what have we done? We have taken this surface. And what did we do to this surface? We observe carefully. What did we do to this surface? We have rotated this surface. Look at that. That's all we've done here. It's a rotated surface. And look at your normal force. It is still perpendicular to the surface. Let us take it back again. Look at that. Perpendicular to the surface. At 90 degrees with the surface. Questions? Right, guys, let us have a conversation, please. Let us talk. Please engage with me. Ask questions wherever you do not understand. And I will be very honest with you. If I don't know the answer, I will tell you straight. I don't know, but I think. I'll be very honest with you. All right, so this is your normal force here. You look at your surface, and then when they say, draw the free body diagram showing all the forces, remember, all you have to do on this is the orientation of your surface. And then at 90 degrees, this will guide you so that you correctly draw your force. Start with that 90 degrees, then draw the normal force. And when you are looking at this, somehow, somewhere, your mind is saying, I'm no longer looking at this Cartesian plane, but I am now looking at the new set of systems which has been created. That is what I'm looking at now. The X is that way, the Y is that way. So that is how we need to orient our thinking and viewing of these things. Then go here. Questions? So that is a short story about normal force. Remember, there has to be a contact between the object and the surface. So when you are looking at something that is suspended by the string, which is not on the floor or any surface for that matter, that we cannot speak about normal force. First, there has to be the contact between the surface and the object. If there is no surface, for example, an aeroplane is flying in the air. So to the aeroplane, there is no normal force, but to the person sitting inside the aeroplane, the person is in contact with the surface of the plane. It's the plane that is not experiencing the normal force, but the person sitting experiences the normal force. Why? Because the person is in contact with the surface of the plane. Hamba physics. Hamba physics. Right, so we're gonna look for those keywords. The second type of force that you can look at is what we call frictional force. Frictional force. Again, there has to be a contact between the two surfaces. Like my hands. When I'm wrapping my hands against each other, there is a frictional force. That is why you can hear the sound. And that is why after some time when I'm doing this, I will feel that there is a heat, which says something. There is energy transferred. We'll talk about that when we do work, energy, and power. But there has to be the contact between two surfaces. That is why the tires of your car, they get worn out after some time. The sole of your shoe gets worn out after some time. Why? Because of the contact between the shoe and the surface. So while you are walking, there is wrapping, there is frictional force exerted on the shoe by the ground. Let me show you something. Let's go to the laboratory. Let's go to the laboratory. Okay, which laboratory do you want to go to? Let's check here. Physics. Right. To find what we're looking for quickly. Say motion. I think we need electricity as well. Okay, let's go into all this there quickly. Join. There is join. So what John is gonna do here as he walks, right? So we're gonna steal the momentum to explain a certain phenomenon. We have noted that sometimes when you touch the handle of the door, you feel something. I'm very certain that you all have experienced. So what happens? This is what happens. As you walk, you are stretching the surface. And during that process, electrons get transferred from the surface to the shoe and all over your body. Now there is an imbalance in charge, in electric charge, but it's because of this force of friction. That is what I wanted to explain, that as you are walking, there is a wrapping between the shoe and the surface. And then during that process, electrons are transferred from the surface to your body. They get distributed all over. Now there is the imbalance in charge. Then you go and you touch the handle of the door because it's a metal, which is a good conductor of electricity. That is what you're going to feel. Number physics. That is what you're going to feel. It's because of that. But what causes that? It's because of the stretching between the two surfaces. Which are those two surfaces? It's the shoe and the mat. So that is what happens, which also informs us automatically. We should also be thinking about this, that on a slippery road, it's not easy to bring the car to a stop. Okay? But on the dry road, it's easy to bring the car to a stop. Okay? On the grass, it's a different story. On the gravel road, it's a different story. On the tarred road, it's a different story. So what am I saying to you? I'm saying to you, frictional force depends on the type of the surfaces that are in contact. It depends on the type of the surfaces. Imagine trying to bring the car to a stop or a standstill on the surface that is ice. Imagine. Now imagine trying to stop a car on the gravel road. So you can see there that there is a difference. On the ice, the car may slide. Why? Because of what we call the coefficient of frictional force. Frictional force. Any questions, ladies and gentlemen? Right, guys, we've got the option of chat in the Teams app. Should you happen to have a question, you can either raise a hand or use the chat option to type in your question. I've got two screens before me. One I'm working on, the other one I'm looking at you guys. So I will be able to see all of your questions. Please make use of that. Let us have an engagement. So frictional force again depends on the two surfaces. Now it's no longer surface, there has to be two surfaces, a shoe and a floor. There has to be two surfaces. Frictional force opposes the motion. Frictional force is parallel to the surface. Let us also take this opportunity to mention that frictional force is a non-conservative force. We speak about this when we do have energy and power, but it's very imperative that we lay this foundation. So if an object is driving towards that direction, remember we said there should be a surface on the road. The frictional force, if this is the velocity of an object going that way, the frictional force will oppose the motion. Excuse me. Number physics. Most importantly, frictional force opposes the motion of the object. And the surface in this case, we normally say the surface must be rough. Rough surface. Look at this, guys. Look at this. Look at this. When you read, we need to understand. Rough, the word rough tells you that there is frictional force. Surface, the word surface tells you there is normal force. So by reading this, you're not just reading like you are reading a newspaper. You are analytical, rough surface. Already there are two forces there which are indirectly mentioned. Rough, frictional force. Surface, normal force. Sorry guys, I need to take this call. I think this call is waiting for me. Just a minute. Você. Você. You can join us, Lucy. I've got here. Sorry guys, I'm back. So frictional force, there are two types of frictional forces. Ladies and gentlemen, two types of frictional forces that you're going to experience. That is, one is static frictional force. That is the first type that you're going to experience. What is the static frictional force? Static means no motion, stationary, static. Okay, so an object that is at rest, when you are trying to push something, there has to be the effort that you must put. And if your effort is too little, the object may not move. What is causing the object not to move? And remember, you have to first be the one exerting the force. What is causing the object not to move, even when you try to push it? It is opposed by what we call static frictional force. Static frictional force. So this is the frictional force which is experienced by an object that is stationary. Let's go back to the lab again. Okay, let's go back to the lab and then try to see if we can find something on frictional force. Let's check here, forces in motion basics. Okay, there's friction. Let's look at that. So look at this guy. This guy wants to push the crate. I don't know why he wants to push it. Can you ask me why? So here is the little guy. He pushes. Look at what happens. Nothing is happening. He pushes. Why? Because the crate experiences in the opposite direction of the applied force, the what we call frictional force. And then look at this. The two forces, while the object is not moving, are equal in magnitude, but opposite in direction. Now the object is moving. Once the object starts to move, it no longer experiences static frictional force. Why? Because the word static means no motion. But when the object is now moving, it experiences what we call kinetic frictional force. The word kinetic means there is motion. That is why even kinetic energy is an energy that the object has because of its motion. Kinetic frictional force. So it's a frictional force that opposes the object that is moving. Right? Kinetic frictional force. So before the object started moving, it was experiencing a frictional force which we call static frictional force. And once the object starts moving, you can see the applied force is now bigger than the frictional force. That is why there is motion. But once the object starts to move, it experiences now what we call kinetic frictional force. If we remove the applied force, you can see that the force does not cause the motion, but it affects the motion. It does not cause, it does not create the motion, but it affects the motion. Number physics, questions. So this is a story. Most importantly, at any given point in time, the static frictional force will always be greater than the maximum static frictional force. Maximum static frictional force. What is a maximum static frictional force? This is a frictional force that an object experiences when it is about to start moving. When the object is at the verge of moving. I don't know if you guys will be able to see, but I want to do a demo here. I've got a table. Okay, let's just lower it. Yes, I may need your help. If someone calls, it's possibly someone from the bank. So please answer the screen. Let's do this. We want to give you something for you if they call again. So I want to show you something, guys. You try to, yeah, I think you can see the table now. I want to show you something. So I've got a box here on the surface. I want the box to slide down. So to aid it, I'm going to lift this. Nothing happens. Why? Because of static frictional force. But when the box is about to start moving, just when it is about to start sliding down, it experiences what we call maximum. When it is at the verge, just before it starts moving, it will experience the maximum static frictional force. How about physics? Huh? It will experience when the object is at the verge, just before it starts moving, experiences the maximum static frictional force. You can see, look at this. When this guy pushes here, you see that the frictional force gets bigger, gets bigger, gets bigger, until the object is about to start moving. So it's still getting bigger. It's not maximum yet, okay? It's not maximum. Now it's that when it is about to start moving, it is at that moment that it experiences the maximum static frictional force. And the magnitude of this maximum static frictional force is equal to the coefficient of static friction multiplied by the normal force. So in order for me to calculate this, I need to know what is the coefficient of static friction and what is the magnitude of the normal force. Then I can tell you. Okay, so this guy here, which we call the coefficient of static friction. By definition, it is a ratio. This guy is a ratio between the static frictional force and normal force. So mathematically speaking, this guy is actually equals to this divided by that, because the ratio is a fraction. Any questions, guys? That's a short story about the frictional force. Any questions? Before we proceed. Stelo, are you good?
Yes. Yes.
Okay. Anybody supposed to?
Yes.
Zama, are you also well?
Yes, I'm well, sir.
Thank you so much. Right, we may proceed now if you are all well. Then the weekend. That young man next to you is Vusi. He's a teacher in training. Yeah, he's a student teacher. He's doing physics, BSc physics. He's married in physics. Bachelor of Science in Physics. So we are working with him for just more than an issue. So can also, when I'm busy, I may just ask him, Vus, come and present on the scene. So Vus goes. Right, so that is a short story about your starting frictional force. Now we move on to looking at the other type of force. We have mentioned normal force, frictional force. We can speak about the special one, which we call gravitational force. I often call it the weight of an object. In physical sciences, the mass and the weight are not the same thing. Weight is a force. Mass is an intrinsic property of an object. Weight is a force which is a vector quantity. Mass is an intrinsic property of an object, depending on the amount of matter. Weight is a vector quantity. Mass is a scalar quantity. It has no direction. It cannot be 50 kg downwards or 50 kg to the left. I'm just 50 kg. That is not mass. That is not weight. There is a difference in weight as used in English and weight as used in science. Okay? So in English, in everyday use, you go to the bottom scale, you say, I want to see my weight. I want to weigh this thing. Not in physics, we don't do that. Not here. We calculate weight, we measure the mass. Yeah. Yes. Gravitational force, the force of gravity, which we normally denote by Fg, others we use W. It matters not which we use. Okay? But this one is a force which is exerted. Okay. Any two bodies. So to understand this, there has to be masses, two masses. Physics says, funny enough, any two objects, they attract each other. That is what this guy said. Any two objects, meaning when you are sitting next to each other, you are attracting each other. I want to attract each other. Any two masses, for as long as I see the word mass, I know that there is going to be the force of gravity. Let us take you back. We said earlier on, for as long as I see the word surface or plane, I know there's going to be a normal force. And we later on said to you, when we see the word rough, what was that? When we see the word rough, we know there's going to be a frictional force. So when you read these words, these are the key words. An object of mass 5 kg, there is a force of gravity, is in contact with the rough surface, mass, rough surface. There are three forces already. Indirectly so, I know that there are three forces. So there has to be the masses here. And this one, we must know, it is directed not just downwards, but vertically downwards. Vertically downwards. There is a force of gravity. It will not matter, it matters not whether the surface is flat like that or the surface is inclined like that. It matters not. The gravitational force is directed vertically downwards. Place a ruler and then draw a line that goes vertically down, regardless of the surface. It is for that reason, partially, it is for that reason that we say the force of gravity is a conservative force because it is independent of the orientation of the surface. Whether the surface is tilted whether the surface is flat, it matters not. The gravitational force is always vertically downwards. Unlike the normal force, look at your normal force, which is a non-conservative force. It depends on the orientation of the surface. But the gravitational force says, I'm always directed vertically downwards. The gravitational force says, I'm always directed vertically downwards, regardless of the orientation of the surface. Number 6. Questions? So that is what we're going to do. And then we remember how to calculate the gravitational force. This is how we calculate the magnitude of the gravitational force. Mass of an object multiplied by the gravitational acceleration. Number 6. Series of those. Right. So that's a short story about the gravitational force. Okay, what else have we not mentioned? Tension force. Tension force. That's the next one. Tension force. Tension force. A tension force is a pulling force. Most importantly, it is a pulling force. You can't push something and experience tension. You must be pulling using either a string, a rope, or a cable. It is a pulling force. So I must either be using a string or a tension. So the key word when you want to know that there is a tension force, you must look for this. You must be pulling something, pulling something like this. See, this is a string. I'm pulling the key using the rope or this thing. What do you call this? What is this? Whatever that you do, this thing. So I'm pulling using this. Then there is a tension on the string. There is a tension on the string. So that is what we need to know. Most importantly, it is a pulling force on the string, the rope, or the cable. So it's some sort of an applied force, so to speak. Hence, we speak lastly about the applied force. The applied force is what we call a push or when you're pushing something, you are exerting a force. Excuse me. When you're pulling something, directly so, you are exerting a force, an applied force. And those are the types of force that you're going to be looking at. So those are the type of forces that you're going to be looking at. Again, you are studying this in conjunction with this document. So we notice we've covered the normal force, we notice we've covered the frictional force, we notice we've covered the static frictional force, we notice we've covered the kinetic frictional force, we notice we've covered which is which. Really mentioned tension, but there is tension and there is applied force as well. So when you are studying, this is your friend. I'm not going to teach you how to define things when you can read. You have no excuse to me whatsoever why you're going to fail to define something when you can read and reproduce that verbatim. I'm not going to forgive you for that. When I say to find something, I'm not going to teach you that you're going to read. But I won't forgive you for failing to define something. Copy to the mind, reproduce to the paper. Simple as that. So read. I don't have a cure for reading. That is why I'm not the English teacher. Right. Questions, guys? Now we speak about Newton's laws of motion. Now let's get into the business. Back to grade level. Newton's laws of motion, the first law of motion. First law of motion speaks about balance and equilibrium. Balance or equilibrium. This is what first law says. It speaks about this balance and equilibrium. Balance and equilibrium. See, this scope here is balanced because it is not foreign. It is balanced by the normal force exerted by the table. So Newton's first law of motion is about that balance and equilibrium. In Newton's first law of motion, there are two keywords that you mentioned. One, an object must be at rest. Object at rest, or an object that is stationary. Object that is stationary. Newton's first law also speaks about a constant velocity. It speaks about this. And it further goes on to say, when these two things are happening, then the net force experienced by such an object will be zero. It summarizes that. An object at rest or an object moving with a constant velocity experiences a zero net force. When I see the word constant velocity, so when you see the word constant velocity, when the velocity of an object is constant, I am indirectly telling you a couple of things. One, the acceleration of such an object will be zero. Two, the net force experienced by such an object will be zero. Three, the work done by the net force on such an object will also be zero. Just by telling you that the velocity of an object is constant, I'm already telling you these three things indirectly. Number physics. What does this mean? Let us unpack it, guys. Let us unpack it. It means that when I add all the forces in the x direction, I'm going to get zero. And when I add all the forces in the y direction, I'm also going to get zero. A vector quantity, vector quantity can only be zero provided the components of such the vector quantity are all zero. This does not mean that the forces are not there. It simply means they are there. But when I add them, the vector sum, not just addition, vector addition. When I add these vectors, these forces, in the x direction, they are going to give me zero. When I add these forces in the y direction, they are going to give me zero. But because we are limited to only two dimensions, it also means even in the z direction, it's zero. Look at your x, y, z, the corner of that house. X, y, z. That's a well-defined thing. Three-dimensional. X, y, z. I'm currently working on the XY plane. If I was walking on the straight line, I was going to be moving on the x plane only. But I'm moving simultaneously in the x and the y plane. That's why I can be here and not just be limited to walking. So for me to experience a constant, to be moving at a constant velocity, the components of all the forces in the x direction must add up to 0. And the components of all the forces in the y direction must also add up to 0. All that comes from one statement, just one statement, constant velocity. Just because we are already here, let us speak about these components and do trigonometry. Remember I told you, physics is applied maths, that's what it is. If you want to master physics, you must first master mathematics. There is no other way, there is no shortcut whatsoever. So we look at an object. You are applying a force on this object of mass m, and there is your applied force F. And the object is moving at a constant velocity. The block is being pulled by that force, which acts at an angle theta to the horizontal. The object is of mass m. Okay, is pulled on a rough horizontal surface at a constant, look at this guys, look at this velocity. We said earlier, when you see the word mass, you must know there is gravitational force. We said earlier, when you see the word surface, you must see the normal force. We also said when you see the word rough, we are rough. When you see the word rough, you must see frictional force. So as you are reading the statement, you are already identifying these forces. Here. So as I'm reading this statement here, an object of mass m, I already know there is a gravitational force. Is pulled, there is the applied force. Is pulled because applied force is a push or a pull. On a rough, there is a kind of frictional force. Horizontal surface, there is a normal force. He says, are you still proceeding to say, at a constant velocity, the net force is equal to 0? So you are not reading a newspaper here. This is information. You are analytical in your reading. You analyze quantitatively and qualitatively. That is why I've got forensic scientists. Bullseye. Question. So I already know that there are 1, 2, 3, 4 forces, which when I add together, it will give me a vector sum of 0. So you go, here is the surface. The object, we treat it as a particle. Why do we treat it as a particle? Mechanics, physics 1, classical mechanics. It's because we are trying to eliminate certain elements, such as having to speak about the center of mass or the center of gravity, the moment of inertia. You don't want to teach them because these ones are still young. You don't want to frighten them about physics. Tell them it sounds physics. Okay, so the object of mass M, from the word mass, comes the gravitational force. Is pulled, we have seen that pulled. The pull is in this direction. On a rough, since the object is moving this way, the frictional force opposes surface at 90 degrees surface. There is a normal force, there is a kinetic frictional force. Hammer physics, hammer physics, hammer physics. Excuse me. At a constant velocity, at a constant velocity, at a constant velocity, my starting point when I see that is that when the force is zero. In my doing the qualitative, now we are doing the qualitative analysis, quantitative. We are quantifying this, we are putting the numbers. Vector sum must be zero. But when does this happen? We said when we add all the forces in the x direction, they must add up to zero. What does this mean? It means that when I add the forces to the left, sum of the forces to the left must be equal to sum of the forces to the right. The same thing applies to say the vector sum in the y direction is zero. It means that when I add all the forces upwards, I must get the same magnitude as the forces downwards. That is what it means. So I have to identify all the forces to the right and all the forces to the left, all the forces upwards and all the forces downwards. But I cannot do that at the present moment. I cannot. Because this up, down, left, and right means what? X, Y. This is what it means. I can move in the X direction to the right or in the X direction to the left. I can jump in the Y direction up and then come back down. However, I've got this guy here who is abnormally oriented. I've got this guy which is abnormally oriented. What am I doing here? It's like this. I'm pulling this table at an angle. I'm giving it a lift and a pull at the same time. A lift and a pull. I am simultaneously lifting and pulling. That is what I am doing simultaneously, so that I'm doing this work in this direction and I'm doing work in that direction. At this angle, that is what I'm doing. And so this will be the components here. This will be the x component, and this will be the y component. When these components are perpendicular, like the corner of the house, at 90 degrees, each corner here is at 90 degrees. Then, the semi-guy comes with his head. Opposite to the angle theta. Adjacent, next to, adjacent to the angle theta. And this will be our hypotenuse. So by so doing, now we are breathing life to trigonometry. This is why we have to study this in math. Because you can apply it. Physics is applied mathematics. You didn't do applied mathematics. You didn't do applied maths. You should have done that. Beautiful stuff. Right, let's look at that. So I want to find these components. So I can define the ratio opposite over hypotenuse, which is the sine of an angle. But which side is opposite? This one. And which side is hypotenuse? Is that. This, by definition, opposite over hypotenuse is the sine of the angle to the horizontal. Angle to the horizontal. And if I multiply both sides by f, it will mean that the y component is equal to f sine theta. The same thing, I can define adjacent over hypotenuse by definition. That would be the cosine the cosine of an angle. Which side is adjacent from my sketch diagram? Adjacent side is fx. Multiplying both sides, we can see that fx will be f cos theta. So I've got the components. I have the components. So I can decompose, I can break down this applied force into its components, which is the x component as well as the y components. So I'm going to be given this component in the x direction, which is f cos theta. And I will also have this component, which is f sine theta, and that is the y component. And then now I can see, oh, now I've got the forces in the x direction. Constant velocity. Now let us unpack the constant velocity. The zero net force. What does it mean? The forces to the right equals to the forces to the left. I go to my free body diagram. I'm looking in the x direction. To the right, I've got this. To the left, I've got this. The two, because it's constant velocity, are equal in magnitude. So the magnitude of the kinetic frictional force will be equal to F cos theta in this particular instance. Because these are the only two forces in the x direction. However, in the y direction, come, look at this, look at this, look at this. Upwards, I've got two forces, the normal force and the y component. Sum of all the forces upwards equals to sum of all the forces downwards. But upwards, I've got the two forces, and those forces are the normal force and the y component, which we have already said is F sine theta. But downwards, I only got what? The gravitational force, which I know is energy. So there we go. Quantitative analysis. Who's others? So that is a story. That is a story right there. Ladies and gentlemen. But we are still, let us bring it back again on Newton's first law of motion. And what governs Newton's first law of motion? These are the two things. When you see these keywords, you must know that. But what does that mean? It means when I add the forces in the x direction and the forces in the y direction, I'm going to add h0. It also means this, that when you do an energy hammer physics. Any questions? So when the net force on the object is zero, the object will either remain at rest or it will continue to move at a constant velocity. But what happens now if the net force is not zero? He didn't stop there. He proceeded, Sir Isaac Newton proceeded to say, now when this net force is not zero, when this net force now is not zero, the object will accelerate. Okay? That is what he said. What is to accelerate? To accelerate means to change the velocity. To accelerate means to change the velocity. Either speed up or slow down. That is to accelerate. So when the net force is not zero now, when there is a net force, non-zero net force acting on an object, the object will accelerate. We can acceleration that will be directly proportional to the net force. Stellar.
Sorry, I want to ask, could you just say that again?
When the net force is not zero, when the net force is not zero, the object will accelerate. The object will accelerate. Okay? But how does it happen? This acceleration of such an object will be directly, that is mathematics, proportional to the magnitude of the net force. So when there is a non-zero net force acting on an object, the object will accelerate one in the direction of the net force. The object accelerates in the direction of net force. The magnitude such that the magnitude of that object will be directly proportional to the net force. That is a mathematical statement which must be unpacked. So what does that mean? It means that mathematically, when I plot the graph of net force against acceleration, I'm going to get a straight line passing through the origin. That's a mathematical statement, directly proportional. What does it mean in simple terms? It means that if the net force increases by 2, the acceleration will also increase by 2. If the net force increases by 3, the acceleration will also increase by a factor of 3. That is what it means. That is a meaning, mathematical, that's mathematics. Directly proportional means if the independent variable increases by the factor a, the dependent variable will also increase by the same factor. Number physics, those are. It doesn't stop there. It further goes on to say the magnitude of this very same acceleration will be inversely or indirectly proportional to the mass of the object. Acceleration is inversely proportional to the mass. What does that mean? It means that if the mass of an object increases by a factor of 2, the acceleration will decrease by the same factor. The inverse of increase is decrease. Thus, that is what it means. So, This relationship mathematically is what we call a hyperbola. Hyperbola. So when I plot the graph of mass against the acceleration, I'm going to get a hyperbola. But, later, listen. When I plot the graph of the inverse of the mass against acceleration, I will get a straight line. That is what it means. That is exactly. That is what it means. So there, when we summarize everything else, when the net force is not zero, the magnitude of the net force is equal to the product of the mass and acceleration. Boom. There we go. Questions. Let's get some questions, guys. Zama.
Yes, my dear.
Are you good, Zama?
Sorry, sir.
Are you okay, Zama?
Yes, I'm good. I'm with you.
Excellent, Zama. And then we go on, we're going to look at lastly, and then so that we can quickly look at one question. Lastly, we're going to look at the last law, which is which ones? Of motion. Now we to the second of motion. All we know is that forces exist in pairs. Okay? Forces exist in pairs. When there is no pair, the other force will not exist, like in this case. See, they exist in pairs. These pairs are of equal magnitude, but opposite directions. That is why when I hit this surface, I'm going to feel the pain because the surface is striking me back. The harder I hit, the more pain I'm going to feel. It's because forces in nature exist in pairs, and those pairs we call them action and reaction pairs. Cause and effect. Action, reaction pairs. So these forces, when body A exerts a force on body B, body B will exert the force of the same magnitude on A, but in the opposite. So when you see two objects connected by anything and they are pulling each other, let's say to that direction, so there is a string. This force, this object is pulled in that way. This object is also pulled in that other way. Action, reaction, pairs. The magnitude of the tension here is the same, but in opposite directions. That is why when we do the calculations, the tension forces will cancel each other out because one will be positive, the other one will be negative, but their magnitudes will be the same. They will definitely, one way or the other, will be solving simultaneous equations. The tension forces will cancel each other out when we add equation 1 and equation 2. That is what is going to happen. You will see. You want to see? Right. Any questions, guys? We're about to start looking at questions now. We are about to just look at one of the first questions. Before we do that, I want to know if there's anyone with a question before we get into this. Okay, great. Okay, the 22nd laws of motion is question 2 of the final examination. This is the paper that was written by the students in 2021 supplementary exam. And this is the question. Out of 17 marks, about 10% of the people, 17 out of 150, slightly above 10%. There is question 2. Okay, allow me to screen grab this. Okay, where is it? Right, so here's question 2. Here's question 2. Now, we are putting this here. You don't think so? No, don't know, the camera will not affect. Yeah. Exactly. These people are called it. You're not worried, but it's sorted. See here, this is what you will see. So the camera is just for them to see what you see. But even without the camera, for the secret, this one will see. Okay, yeah, you can see. Okay, good. So let's look at this. An 8 kg block. There is a mass there, 8 kg block. Here is the 8 kg block. I already know there is what? You are doing that whilst you are reading. Even before you get to read the questions, while you are reading the statement, you are analyzing. On a rough, let's wait for the direction. Horizontal surface at 90 degrees. Is connected to a 2 kg block by light inextensible string. So when I see that string, I would know that there is going to be tension force. Passing over a frictionless pulley as shown below, the 8 kg block moves at a constant speed. When pulled by a 29.6 Newton horizontal force to the right, now I know the direction of the frictional force. The frictional force opposes the motion, so it must be to the left. Because there is motion, it's kinetic frictional force, because it is moving but at a constant speed. About physics. So this is what you do with the motion. Even before you go to looking at the questions, you already have identified 1, 2, 3, 4, 5 forces. The other one is already brought for you. 5 forces are acting on the 8 kg block. Right. So it is connected to the second object, which is 2 kg. And there is also a string. Look at this one. Remember, tension force is a pulling force. It's a pulling force. So this object is kind of pulled upwards, while this one is pulled to the left. They are pulling each other. Newton's third law of motion says these tension forces must be of equal magnitude but opposite directions. Remember the function of a pulley. A pulley changes the direction of the force, not the magnitude. Okay? Instead of this tension being this way and this way, there is a pulley which changes the direction of that tension force, but not the magnitude. Only the direction, not the magnitude. That is what it does. Grade 9, Natural Sciences. Grade 9, Natural Sciences. So we have analyzed this. So we've got a free body diagram of each of the two objects. This solves almost 60% of the problem, even without looking at the questions. 60% of this question has already been solved. I haven't even started answering the first question, but I've got 60% of this. Look at it. State Newton's second law of motion. I told you guys I'm not going to be teaching how to define things. I will teach you physics, not English. Okay, definitions I'm already. You can read, memorize, and reproduce the definition. I'm never going to forgive you for failing to answer the question that says define or state. Ever. Because there's no excuse whatsoever. So when we define things again, we go to this, the accepted definitions are the ones that comes out of this document. Nothing more, nothing less. Directly from the examination guidelines, which I'm going to share with you via the WhatsApp group. Okay? So we're going to this directly to this document, a second law. State Newton's second law of motion. When a net force, that is what you're going to do, verbatim. Do not paraphrase. This is not plagiarism. We do not paraphrase. We copy as it is. So you take this as it is onto your exercise paper. State Newton's second law of motion, blah, 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 that. So you're going to do that. It's not my job. That one is entirely on you. Straight. Question 2.2. Draw a label for body diagram for the 8 kg block for 5 marks. 5 marks, free body diagram. The marks tells you about the number of forces. Let's just go and count them. Are they 5? They should be 5. 1, 2, 3, 4, 5. Ha. Perfectly so. Perfectly so. And each and every single force is justifiable by the statement. We have read the statement. And from a statement, we highlighted the keywords. Each keyword gave us those forces. So we can easily. Free body diagram, question 2.2. 8 kg block. The 8 kg block, we have seen there is an applied force, there is a normal force, there is a tension force, there is a kinetic frictional force, and there is the gravitational force. We're done. Just like that. We're done. Calculate the tension in the spread. Again, when I start this now, let's go back. We were told constant speed. When you see the word constant speed, in your calculation, the first thing you do is what? In the motion. F net is equals to 0. That is justifiable by what? The object is moving at a constant speed. So it's a question of Newton's first law of motion. And what did we say this means? The sum of all the forces to the right, I only have the applied force, is equal to the sum of all the forces to the left. That is what we've said. But equally so, also said the sum of all the forces upwards is equal to the sum of all the forces. There is only a normal force up and only a gravitational force downwards. That is what we have said. Let's go back and check. We were given the magnitude of the applied force, 29.6. We also were given the magnitude of the frictional force as 10 newtons. 29.6 applied force. So we know the magnitude of our applied force, 29.6. We also were given this as 10 newtons. Oh, look at that. Look at that. It's a linear equation, 29.6 less 10. And that gives us what? 19.6. Okay, before I proceed, I'm going to take a pause for a few questions. Any questions, ladies and gentlemen? Okay, I think that was a straightforward thing. So I think you now begin to see it through. Oh, start off.
Sorry, I wanted to ask, can you re-explain for the frictional or the frictional acceleration?
Can you repeat that again?
So the accelerate, you said Fa equals Ft plus Fk.
We are adding the forces to the right. And we are adding the forces to the left. We are looking at the free body diagram. To the right, there is only the applied force. But to the left, there are two forces, the tension force as well as the kinetic frictional force. I don't know if that assists you a study.
No, that did. Thank you.
Great, fantastic. Then they proceed on. Before we proceed, Zama Space 2, are you guys good? Okay, I'll assume that you're all good. So that was a question 2,3. Now we go to question 2,4. Before question 2,4, there is a statement. They are saying now, the 29.6 Newton applied force or horizontal force is now increased to 50 newtons. Apply Newton's second of motion to each block and calculate the magnitude of the acceleration. They want now the acceleration because we have now increased the applied force. Now the block is no longer moving at a constant velocity because we have now increased the magnitude of the applied force. So we're gonna do exactly that, 2,4. We are looking at the 8 kg block. This is your compass. This is what will help you to navigate to this problem. It is the free body diagram. Like I said, free body diagram solved or answers 50% of your questions. This is your applied force, gravitational force, tension, as well as the kinetic frictional force and the one force. Okay? Acceleration is in the direction of the net force. The object is moving to the right. So the acceleration will also be directed to the right. Now we are no longer looking at an object that was initially moving at a constant velocity. We have now increased the applied force. So the net force is no longer 0, but this time around, the net force is equal to NA. So when I add all these forces, now at this point I have to assign the directions. The direction of motion is positive. The object is moving there. So that the opposite directions are positive. Let me repeat this again. The direction of motion, the object is moving this way to the right. So the direction of motion is a positive direction. So that what in the opposite direction is negative direction. So I'm adding these forces along the x direction, which are the applied force in the positive direction. In the negative direction, I've got the kinetic frictional force. I've also got the tension force. Both these are in the negative direction. The applied force has been increased to 50 newtons. They didn't say anything about the frictional force. But we also have calculated the tension force. We found it to be 19.6. And this is the 8 kg block. Questions? You can add all of that. What does it look like? 20.4. It looks like 20.4. And then we can divide the both sides by 8, and what we get 2.5. 55 meters per second squared. That's it. Questions? Right, so that will be your acceleration. I hope you guys are seeing here. You are making notes and you are taking some skills out of each. Looks like there is a problem in progress. They still want us to calculate the tension and the strain. So the second question now says, our solution cannot be correct. You see what this question suggests? Because they want us to recalculate the tension. It means that when they increased the applied force, the tension force was also affected. That's why they want us to calculate it again. So this cannot be entirely correct. So if that's the case, how do we solve that mystery? We don't have to stress. Let us put in what we know. This is 50, this is 10. We do not know what this is. This is the 8 kg block. So this is 40, 50 plus negative 10 is 40. Minus the tension force is equals to 8 kg. There is nothing more you can do here with this point for the 8 kg. So we need what? The second block. Okay, so we need to look now at the 2 kg block. Remember, let's go back to the 2 kg block. There are two forces only, and that is the tension force, is the S, the gravitational force, there is a tension. So let us draw that, because we do need our navigator. The free body diagram, whether they ask you to draw this or not, but you need it. You need it because this is your navigator, this is your canvas. You need it to navigate through this. So the direction of motion, this one will be moving upwards, positive, and this one is a negative direction. Once again, the net force is no longer zero, but it is now MA. In the positive direction, I've got the very same tension framework, but in the negative direction, I've got the gravitational force. So I do not know this. I know the mass, I know the gravitational acceleration. I know the mass to 8. So you add this, it gives you negative 19,6. And there is nothing more you can do. Remember earlier on, I said to you, the tension force will find a way to cancel each other. And see, look at how that way comes in. So I'm going to put these two equations side by side. Equation 1 and equation 2. I'm going to put them side by side. Allow me please to go with this. Let's go. Yeah. Okay, I want to take this here. And look at that. Look at these two equations. And I'm going to combine them straight. When I do so, look at what happens. This tension is positive, that tension is negative. And I can combine what is left. At the top, I've got negative 19,6. At the bottom, I've got 40. To the right, I've got this, and I've got that. I'm adding these two. Tension and tension, they have found a way to cancel each other out. And what do we get? What do we get, guys? 20,4 and here 10,8. And when you divide both sides by 10, you get what? 2,04 meters per second squared. Done. Questions? So this is how we're going to do it. The tension, if they do not cancel each other, you must know there is something wrong with them. Because they are of the same magnitude, but in opposite directions. As per Newton's black law of motion. Questions? Last but not least, we've got about 10 minutes. They want us now to calculate the tension in the spring. So how do I find the tension in the spring? Back substitution, either into equation 1 or to equation 2. Excuse me. So if you wanted to use equation 1, you've got 40 minus the tension force is equals to 88. Now let us substitute this acceleration here. So we've got 40 minus tension here, force is equals to 2.04. And then we'll see what we get here. 16,32. And then we have got 40 minus the tension force. Take the tension force, which is negative, to the left, to the right, it becomes positive. Taking 16,32, it becomes negative. And what do we get there? 23,68 newtons. 23,68. That's it. So somebody might be asking, what if I had chosen to substitute this into equation 2? You would still get the very same answer. What was our equation 2? Equation 2 was, is our equation 2. Tension force minus 19,6. Tension force minus 19,6 equals to 2. We take the very same acceleration, we substitute it here. We found, what was it again? 8,04. Was it 8,04? 2,04. Oh, sorry. And what do we get here? 0.08. Tension force minus 19,6. Take this to the other side. We get 19,6 plus 4,08. We should get the very same. It should give us the very same thing. 23,68. So it matters not whether I use equation 1 or equation 2. That is why we call this in maths simultaneous equations. Simultaneous equations. And that's it. Guys, that is my story for you today, I don't know if you've got any questions for me. Supposedly. Zama.
So I understand everything from today.
Yeah, this will be the end of our session for today, Zama.
So sorry, sir, I'm not done. I was saying, will you please add me in the group? I'm not in the group.
Okay. Can you send me your email address? Use the chat option. Just type in your WhatsApp number, or rather the email address.
So should I send my email address?
Both the email address and the WhatsApp number.
Okay, thank you, sir.
So if there is anyone else who also is not in our WhatsApp group, please do join, because I'm going to send you these notes as they are. In fact, before I forget, let me just save this before I forget. So if there is anyone else who is not in our WhatsApp group, please use the chat option, keep in your WhatsApp number and the email address. I will send you the link to join our WhatsApp group. Just now make this PDF. Okay, where is this? Okay, guys, as quite delay or one such. I need to email this to myself. We are done for today. We're gonna meet on Wednesday. 8:30 in the morning, Mr. Magai will come in for mathematics. From 8:30 to 10:30, then from 11 up until 1 o'clock, I will be back for physical sciences. I don't know if there are any questions. Zama has sent her WhatsApp number and the email address. Stella?
I wanted to ask about what would be the additional work?
Pardon? Oh, yes.
I'm saying,
when I get something, I will send you a set of questions for this topic, and then I'll tell you which questions to answer, which I'm expecting you guys to submit. Please, we're gonna be getting the work. You do your homework, you send me your solutions via WhatsApp, directly to my WhatsApp number, so that I can look at your work individually. So I'm definitely going to be sending you guys some questions. It's a compilation of questions for you to do, and I will tell you which questions to look at. Okay?
okay.
Okay, any further questions? If there are no further questions, ladies and gentlemen, thank you for tuning in today. Let us meet again on Wednesday at 8:30. Mr. Makai in the morning for mathematics, and then myself from 11 up until 1. We shall meet. And I'm going to send you the notes, as well as the set of questions, as well as the examination guidelines, as per promise. Other than that, thank you guys. Bye-bye.
Bye, sir.
Cheers. Bye, guys.
Sorry, sir. Sorry, sir. Gosh, okay.